executed to calculate the case efficiencies. After that, we have to go with summation operation. Then we have to solve that summation and to establish order of growth. This is the general plan we have discussed in our physical session. In today's session, we are going to discuss about matrix multiplication analysis part. Analysis of non-recursive algorithms. One of the example, matrix multiplication. In matrix multiplication, we have to get two input matrices. That is the input that is given as two input matrices, size n cross n size. For that, we have to create two arrays, one for matrix A, another one is for matrix B. For both matrices, it starts with array index 0 to n minus 1. Look at the first line. We have to start the algorithm with capital letter, followed by the function name, whatever you want, you can write it. For this example, it is written as matrix multiplication of A of 0 to n minus 1, comma, again it is 0 to n minus 1. In previous examples, we have discussed with only one array, that is one dimensional array. For this matrix multiplication, we have to go with two dimensional array. That means rows and columns, number of rows and number of columns. For that, we have to create index for rows and columns separately. For that, we have to write the array declaration like this: A of 0 to n minus 1, comma, 0 to n minus 1. The first one is for rows, the second one is for columns. Similarly, for the second matrix B, we have to go with matrices B of 0 to n minus 1, that is row index, followed by column index as 0 to n minus 1. This is the way to write the function for computing matrix multiplication. Followed by, we have tried the problem description, that is the second line, multiplies two square matrices of order n by the definition based algorithm. Here we have to use two matrices, n cross n matrices as input. Finally, we have to go with matrix multiplication operation. The result will be stored into a resultant array matrix that is called as C. For this example, C is the resultant matrix. C equal to AB. That means multiplication of AB will be stored into C. For this case, first we have to go with computing A and B matrices. A and B. For that case, we have to go with looping concept. I is for matrix A, J is for matrix B. So the index ranges from 0 to n minus 1 for both the cases. Initially, the matrix multiplication we have to compute as 0. After that, we'll go with computation process. For that process also, we have to go with one more looping statement, k equal to, that is for resulting array. For the resulting array, 0 to n minus 1. Resulting, we have only one array, only one matrix. Similarly, we have to go with rows and columns, that and all. For that, here we used k as a resultant variable array. So C of I comma j, initially it is assigned with 0 plus the formula A of first matrix followed by resultant matrix multiply with B into B of resultant matrix comma j. This is the way to use matrix multiplication with this logic. And then finally we have to write the result with the help of a looping variable capital C, that is written C. So this is very simple algorithm to understand the mathematical analysis of matrix multiplication. Here, the first matrix I is for matrix A, second matrix B is for second matrix B. For that looping variable J is used. Then for matrix C, that is resultant matrix, it is used as K. So next one, we are going to see the analysis part. Okay, before move on to the analysis part, let's discuss about the general plan. In general plan, the first step we have to fix the input size. Here the input size is n cross n. Second one, basic operation. Here the basic operation is multiplication. Matrix multiplication is the basic operation. Then we have to go with number of times the basic operation is executed. Finally, we have to go with summation, then followed by simplification. The next slide, let's see the analysis part. Just observe this. In the first step, we have to identify the input size n cross n matrix. Then basic operation, inclusive of matrix multiplication followed by addition. Then basic operation, based on the basic operation, we have to form a summation relationship for each looping statement. For example, I loop I to n minus 1, that is the range we have fixed in algorithm. It at one time it executes only once. So I 0 to n minus 1. Similarly for j and k also. Okay, next one about this simplification. For the simplification, m of n equal to summation I equal to 0 to n minus 1, j equal to 0 to n minus 1, k equal to 0 to n minus 1, 1. So we have to start from the right end. First, we have to start with k, looping variable k. K equal to 0 to n minus 1, 1. For this, we have studied one formula n minus k plus 1. Here n value is n minus 1, k value is 0 plus 1. n minus 1, n minus k plus 1. Here n value is n minus 1, k value is 0. So n minus 1 minus 0 plus 1. Minus 1 plus 1 will be cancelled. So we will have only n that is written here. For k equal to 0 to n minus 1, 1, we found n value as 1. Now we have to move this n to the front. At the front of this summation, we will have again summation j equal to 0 to n minus 1, 1. Use the same formula, you will get another one for j, then move that into outside. Otherwise, you can keep it the same side, it becomes n square. So when you move this n square to outside, it becomes summation I equal to 0 to n minus 1, 1. Again, you apply the same formula n minus k plus 1, you will get n minus 1 minus 0 plus 1. Minus 1 plus 1 will be cancelled. You will get n, one more n. So we have 3 n's for this summation operation. So we will have the result as n cube. So the time complexity of matrix multiplication operation is theta of n cube. Do you have any doubt on this slide? I hope you are able to understand this easy summation operation. Okay, fine. Let's move on to one more example, which is based on non-recursive. Very simple case. Just we are going to count. Find the number of binary digits in the binary representation. Just we are going to find out the number of digits alone. For that, we have to start with the count one by input value number n integer, output numbers, number of binary bits. So we have to go with looping operation. We have to apply the same operation for n values greater than 1. If n equal to 1, then the result 1.